As for the introduction, this study explores about the production of a stand fan using concurrent engineering approach. In the concurrent engineering approach, it starts with the idea, goes to project design, and then manufacturing, after that assembly, and lastly to maintenance before it goes back to the idea. So it's a loop of process that has to be done to fulfill the concurrent engineering. Next is the objectives. The first objective is to implement the method of concurrent engineering in developing a product. Second, to modify the design of the knob of the stand fan in terms of material. And the third one, to analyze the fan knob design and develop a prototype.
The next slide is a benefit of concurrent engineering. As you can see here, the process of concurrent engineering can save more time compared to the sequential engineering. Thus, it gives a lot of benefits such as reduced cost, increased quality, and so on. Moving to the methodology, as you can see here, this is the framework that we comply in this project to produce the better stand fan. The next slide is the result analysis. In sketching, based on the figure, there are 3 different sketches of fan. However, each of the fan have their own strength and weakness. So based on customer requirements, sketch C is selected because the fan can be adjusted, aligned, and it can be rotated 180.
Next, in the questionnaire, as you can see, there's a bar graph showing that how do you rate the existing stand fan shown below. So this is the stand fan. So according to the customer responses, most of the respondents prefer the existing stand fan. In the next questionnaire, what criteria do you look for when buying a stand fan? Of all the 75 respondents, 57 of them said that price is the main criteria they look for when buying a stand fan. Second will be quality, third will be brand, and lastly it will be lifespan. In the next questionnaire, what is the characteristic you wish to improve on existing stand fan? Okay, as you can see in the pie chart, the percentage of characteristics to improve on the existing stand fan are lightweight, easy maintenance, and energy consumption. As for the next questionnaire, do you think number of fan blade affect the movement of the wind? So 75 of them responded that based on chart 7, most of the respondent believes that the movement of the wind is affected by the number of fan blade.
The purpose of this project is basically based on the customer requirement. The Quality Function Development QFD method is used to find the requirement of the customer regarding the product and the product quality characteristics. As we know, Malaysian climax is the category as the equatorial, being hot and humid through the years, since located near the equator. Thus, 4 critical specifications used to sort out the best quality that need to be prioritized in the stand fan design, which are performance, competitive price, appearance, and lifespan.
First selling parameter is 20, while the improvement parameter is 2. Based on 3 consideration metrics are principal 18, 19, 28, and 1. What is the most feasible solution with a cost constraint for this for inventive principle? 1. Make it easy to disassemble an object and increase its degree of fragmentation or segmentation. Made by theorists can be concluded that in order to solve the problem, the FMEA is the best solution.
The next slide is FMEA, which is failure mode and effect analysis. As you can see in this table, what we can conclude is that the fitting knob shows that the most significant effect to the fan, which have to be redesigned using concurrent engineering in order to make it more safe.
The best stand fan design assessed using AHP, Topsys, and VICO by considering 4 key attributes including price, performance, lifespan, and appearance. The final ranking result is shown in table. The results show that the highest rank is the Panasonic. The result for Topsys and VICO is same for 5 brands. But if compared with AHP rank, the value is roughly not same with Topsys and VICO, except for Panasonic rank 1 and Kind rank 4.
There are 3 types of materials that are preferable for blade. We do the ranking method to choose which is the suitable materials for the blade, and stainless steel got the first ranking among all. From the tables on the comparison of stainless steel, mahogany woods and nylon properties, all inhabit good property for the construction of the knob, but the best is nylon because it is more flexible, although nylon has low density compared to stainless steel, but it is still capable to give enough strength for maximum torque. The design efficiency of the values for manipulation time and insertion time from the standard table as provided by Boothroyd and Dewhurst are therefore selected on basis of the handling codes and insertion code. As you can see, the design efficiency of the product is 0.201. This is the calculation for assembly cost after applying manual Boothroyd Dewhurst DFA methods. For the labor cost, it is around 80 ringgit, and for the calculation of assembly cost, the assembly time must be multiplied by the labor cost, which is the assembly time is 268.33 second multiplied by RM80 per 3600 second. And the assembly cost we got is RM5 ringgit 0.96 cent. This is the table for cost analysis. This table shows the total cost for the parts of product produced depend on their processes. After we calculate all the cost to make use all parts, we can get the total how much of the parts cost and the whole total cost for the product that need special process to produce the part. For the cost analysis, the total cost is 132 ringgit 40 cent. And this is the table for the cost analysis of OEM parts, which is something that we can buy directly from the shop. And the total cost of the OEM part is 18 ringgit 30 cent. After we know all the costs for assembly costs and for the manufacturing cost, we can calculate the total cost for one stand fan. For this one stand fan, the total cost is 156 ringgit 26 cent.
When say about sustainability issue, is about how to determine the environment impact of the product. Life cycle assessment is the method to assess the environmental impact of the product throughout its entire life cycle, from the procurement of the raw material through the production, distribution, use, disposal, and recycle of the product. The figure shows the result of comparison of the knob designed by using three-type material. To conclude the comparative result of the environment, the mahogany is the lowest impact material of the carbon footprint, total energy consumption, and water eutrophication. In the case of the air acidification, the lowest environmental impact is nylon 101.
View is on the left while the detailed design is shown on the right. For the simulation purpose of the FEA, the fixed geometry applied taut and mesh is used in order as the parameter. The FEA shows the results that design one have the best solutions for the problem based on the FMEA. There are three parts included under the design state, which are 3D modeling, details design, and the bill of material. Meanwhile, under the analysis stage, we include the finite element analysis or FEA as our final analysis. The finite element analysis consists of the stress, strain, and displacement of the object. Based on the stress of the object, design 1 shows the highest stress, which make it is the suitable fans used. In the maximum of strain also shows that design 1 have the highest, and in the displacement also show that design 1 is the highest. We can be conclude that design 1 is the most suitable design in order to solve the problem.
The following conclusion reflect the research objective that stated in Chapter 1. All the objectives were achieved successfully throughout the study. The findings are summarized as follows. Number 1. Throughout the result analysis that have been conducted, it was found that ideation, project design tool, design, and analysis is the most effective way to produce fan stand with concurrent engineering. Number 2. In this research, the tools that has used are used to determine the most significant factor in order to improve the design of the stand fan. Number 3. The most significant factor that affect the design of the stand fan are price, performance, lifespan, and appearance.